Looking at another example, let's say we want to find the volume of the solid of revolution obtained by revolving the plane region bounded by y equals 0 and y equals 4 minus x squared about the line y equals 0, in other words about the x-axis. So the first thing you do in this kind of exercises is to sketch the plane region that you want to revolve. So here we have y equals 4 minus x squared. This is going to be 0 when x squared is 4, in other words when x is plus or minus 2, so it intersects the x-axis at x equals -2 and at x equals 2, and the region we are looking at looks like that. Now we are rotating this region about y equals 0, and therefore for each x between -2 and 2 we're rotating a line segment that looks like that. We're rotating it about the x-axis, and therefore what we obtain is a disk of that sort. Again, that disk sits in a plane x equal constant, which should be a plane vertical perpendicular to the plane of the board. It is now tilted so that we can see the cross-section. So this solid of revolution that we obtain, to obtain its volume now, all we need to do is integrate the surface area of the cross-section. We already have observed that the cross-section is a disk. All we need to know about that disk to know its surface area is its radius. And you see that for a given x, the radius here is going to be given by 4 minus x squared, because this is the y-coordinate corresponding to that particular x if we're along the curve. So the cross-section is a disk of radius 4 minus x squared. That means that its area is pi multiplied by the square of the radius, in other words the square of 4 minus x squared. The square of 4 minus x squared is x to the 4th minus 8x squared plus 16. And now the volume is given by the integral of this function from -2 to 2. Calculating this integral, well, first you could observe that we're integrating an even function on an interval centered at the origin, so it's really just the same as 2 times the integral from 0 to 2 of that function. Regardless, I can pull out the multiplicative constant pi, get an antiderivative for x to the 4th, that's x to the 5th over 5, 1 for 8x squared, that's 8 third x cubed, an antiderivative of 16 is 16x. Evaluating this function between 0 and 2 and multiplying the result by 2, this is what we obtain, 2 pi multiplied by this expression, which simplifies as 512 pi divided by 15. Now to conclude, let's look at yet another example where the rotation this time is going to be about x equals 0, in other words the y-axis, so vertical line. And we want to find the volume of the solid of revolution obtained by revolving about that line, the plane region bounded by this y-axis x equals 0, the horizontal line y equals 1, and the curve of equation x equals tangent of pi over 4 times y. So as usual, first we need to sketch the graph, and this looks like that. And so the plane region that we're talking about is this red region here. And now we rotate about the y-axis. Now remember that what we need when we rotate about a certain axis is the cross-section by a plane that is perpendicular to the axis of rotation. So now if the axis of rotation is a y-axis, planes that are perpendicular are planes y equal constant. Therefore they are horizontal planes that are perpendicular to the plane of the board. So in other words, you take a certain level y, and for each y between 0 and 1, you look at the line segment in the region that you're rotating that corresponds to this y equal constant, and rotate it about the y-axis, and you obtain a disk like that. In doing so, we obtain solid of revolution that roughly looks like that, and all we need to find its volume is to know for each y between 0 and 1 what is the area of the cross-section, We've already observed that this cross-section is a disk, so all we need is the radius of that disk. And you see that for a given y, because this point here is on the curve x equals tangent of pi over 4, the radius for that particular y is going to be tangent of pi over 4 times y. In other words, a cross-section by a plane y equals constant is a disk of radius tangent of pi over 4y. The area of that disk is pi multiplied by the square of that radius. Therefore, we get pi tangent square of pi over 4y. Now, to obtain the volume of the solid of revolution, we need to integrate that function from 0 to 1. There's a typo here. Instead of a of x, it should be a of y. Of course, this is a function of y. So now I have to calculate this integral from 0 to 1 of tangent square pi over 4y dy. I have tangent square of something that is not just a variable y, but a constant multiple of it. So we're going to start with simple substitution, where I substitute for pi over 4y the new variable u, in which case du is pi over 4 dy, or in other words, dy can be replaced by 4 over pi du, which is what I'm going to do. So dy is 4 over pi du, and then I have tangent square u, and for the bounds, when y is 0, u is also 0, when y is 1, u is pi over 4. Therefore, my integral becomes pi multiplied by 4 over pi du, and integral from 0 to pi over 4 of tangent square u. The pi cancels out, and I obtain 4 times the integral from 0 to pi over 4 of tangent square u. Now I'm going to write tangent square u as tangent square u plus 1 minus 1. The reason why I do that is because we know that the derivative of tangent is secant squared, which can also be written 1 plus tangent squared. In other words, if I have tangent squared plus 1, then I have an antiderivative, namely the tangent. That is why for the antiderivative we get tangent of u minus u for the antiderivative of minus 1. We evaluate that function between 0 and pi over 4, multiply the result by 4. At pi over 4 we get 1 minus pi over 4. Multiplying all that by 4 we get 4 minus pi. And at 0, tangent u and u are both 0. So we obtain 4 minus pi for the volume. Now turn to the next video for cases where the cross-section is not quite a disk, but a washer.